Hi everyone, today in Integrated Math 1, we're going to go over Chapter 14, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over triangle proportionality theorem. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. Let's look at our example. So we have side BE, which is parallel to side CD, which is shown here with our little arrows. And then we also know that AB is proportional to BC, which is equal to AE, which is proportional to ED. So this piece over this piece, and this piece over this little piece. Alright, so notice here, it is called the converse of the triangle proportionality theorem, which means it's a flip version of what we just learned. So let's go straight to our example. If AE is proportional to EB and CD is proportional to BD, then we know that sides AC is parallel to sides ED. So remember, it's just a flip version. It's just the reverse of the one we just talked about. Alright, now let's go over a midsegment of a triangle, which is a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle has three midsegments, and the midsegments are right here in our picture. So they make RP, PQ, and QR. So let's go over the triangle midsegment theorem. A midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So here we know that J and K are the midpoints of FH and GH. With that, we also know that JK then is parallel to FG. Then with that, we also do know that JK is equal to 1/2 of this FG. So keep that part in mind. You're definitely going to be needing that one. Proportional parts with parallel lines. So this is another case of the triangle proportionality theorem that involves three or more parallel lines cut by transversals. And notice that these ones are extended out a little bit more, but we have three parallel sides. Alright, proportional parts of parallel lines. If three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So we have our parallel sides, AE, BF, and CG. Then AB is proportional to BC, and EF is proportional to FG. Congruent parts of parallel lines. If three or more parallel lines cut off by congruent segments on one transversal, then they cut off congruent segments on every transversal. So for example, we have each of our parallel sides, which are shown here. And then we also know that AB is congruent to BC. If we know that, then we also know that EF is congruent to FG. And there we go.